Howdy, y'all. Happy Tuesday. Welcome to Some Antics. Today, I'm joined by Sage. Hello, Sage. Welcome to the stream.
Hey Ben, really excited to be here. Thank you so much for having me.
Absolutely.
I'm really excited to see the magic we create today.
Yes, absolutely. So, for anyone who doesn't know, this is Some Antics. This is a weekly stream where I bring on guests from around web development and web design to teach me something about building great user experiences for the web in a hands-on way with a focus on accessibility and core web technologies. And today we have Sage. Sage, you're the creator of Chakra UI. But I can't, no introduction I could give could do you justice. So would you like to introduce yourself for anyone who hasn't seen you around yet?
Yeah, for sure. So my name is Segun Adebayo. My nickname, or should I say Twitter name, is Sage. So you can call me Sage if you find it hard to pronounce my name, for sure. So I'm the creator of Chakra UI. I'm a GitHub star, and also recently the creator of Zag.js, and I currently work at Vercel as a software engineer.
Awesome. So you mentioned Zag, and that's kind of what we're going to be diving into today. First, can you give us at a high level, like, what is Zag?
Yeah, for sure. I mean, each time I have to explain or talk about like what is Zag, I always start from like why Zag. I think that like that's a much more interesting place to start from. Then I can get into the what, and I see like so the journey behind like why Zag was created always like I mean predates like Chakra UI and like all of the work that we've done. I mean at Chakra UI. So earlier when we launched Chakra UI, we're trying to build like a system that would help people, that would give people the composable pieces they need to create an accessible website or application like really fast. So think of like Lego bricks that no matter how you put them, they're always like performant, they're always accessible. It's just like out of the box, it just looks awesome as well. Right. So that was kind of like the goal we set out to solve. Now getting into that, I mean, 3 years after getting into that, we were seeing like lots of people come to us like, Chakra UI is awesome. I mean, first of all, can we get more complex components? Can we get like a date picker, a date range picker? Can we get a carousel? We literally want to get like everything possible we can get. And then the next one then goes like, can we get Chakra UI in Vue.js or in Svelte or in Solid.js? And then just like, with the popular and growing open source project, it starts to take a toll on your mental health and physical health when you try to solve all these problems in parallel, right? And I took a first stab at this by trying to set up a Vue.js team to say, let's get Chakra UI into Vue. Let's work on Vue stuff and let's get it rolling. First of all, it took maybe like 8 months to just get like the current version of Chakra UI into Vue, and I noticed that like the amount of bugs they had to solve is either a bug we've already fixed within the React project or a bug we don't know about. And then it's like we probably have to like then start to sync, like check the issues here, check the issues there, and like compare and sync to see like how are we solving issues and accessibility concerns over time, right? So that became a very daunting process, right? And then in the end, I thought about like, is there a way we could just like model the logic of all these components in a single like framework agnostic way without having to depend on like React and Vue and Solid, because each of these frameworks come with their own like, should I say, like mental overhead, things you have to learn, things you have to know in order to maintain, not just to build, but in order to actually maintain and improve them over time. There's a certain level of like mastery you need to have for these frameworks. And in the end, I see our roles as software engineers not just being like a framework expert, but actually being like the true software engineer that we should be, which is actually modeling complex systems in a way that is accessible, in a way that's composable, in a way that can be maintained and improved over time. Right. So I see the software engineering role as a system design role, not just like a UI, let's just get this UI working type role, right? So it's kind of like how the perspective I decided to sort of like look at this challenge from. And then I stumbled on the concept of Statecharts, right? And then it occurred to me that this might be the missing piece that I'd really love to see within Chakra UI's ecosystem. And like, I mean, I just like I took a while to sort of learn about Statecharts. I stumbled on XState, I stumbled on David Koshid. just like you mentioned, is like, I mean, I took a couple of his courses, and that
Mhm.
actually helped me actually get started into state machines and building maybe like one or two of the components we have in Chakra UI, just like just brought the light bulb on in my mind. It's like, oh, okay, this is actually like the way to go, right? So Zag.js right now is a collection of composable, it's a collection of composable components, logic, basically. So it's just like component logic built with state machines. And we've already accounted for things like the event handlers and the accessibility requirements for all of these components. And we just say, hey, here are all of the headless components. You style it however you want with CSS, with Chakra UI, with Tailwind, whatever solution you prefer. But then you're sure that the logic, the accessibility works exactly as you'd expect them to.
That's awesome. And so, you mentioned like state charts, state machines. These were the missing piece that enabled you to build this kind of like framework agnostic tool. Can you talk about like what they are and how they fit into the picture? Like, why were they the missing piece?
Yeah, I think like the idea or the concept behind Statechart started like, I mean, it'd probably be like almost 30 years ago from today.
Hmm.
Yeah, it's actually been in existence for quite a while. I think 1960 or 57, one of those dates. And like the key thing here is that like these systems have been used in like places like the avionics system, the people that design electronic systems. They actually use state charts to model the complexity within the systems. Then it occurred to me that like I think the web is also that complex. It's just maybe complex in subtle ways, right?
Hmm.
So that is kind of like what got me into that, because as a developer, when you get into like handling like on key down, on key up, on pointer down, on mouse up, on mouse down, on transition stuff, like all of these weird things. I mean, composing like all of these different event systems to make sure that you build your components in a way that's accessible, in a way that's performant, actually takes a lot of time, right? And it takes a lot of testing, takes a
Hmm.
lot of like mental effort to actually get right. And I think the biggest one is like it takes a lot like to be able to maintain all of these kind of complex components. If you build them with vanilla JavaScript, with querying the DOM and listening to the events, and then updating some states and like syncing all of these states together, it turns out to be a very complex, messy soup of code that you have to deal with over time. And one of the things I've seen with component libraries over time is they become robust. And with robustness, they become like less maintainable. Even the creators of these libraries tend to like just like try to run away from this library because like there's so much like if conditions and so many like hacks just to make things work correctly the way you'd want, right? And not to talk of browser inconsistencies between Safari and Chrome, inconsistencies between Firefox and Mozilla, and Chrome
Hmm.
and even Safari as well. So there's so many like layers to this complexity that like, I mean, just using the vanilla approach would definitely work if you ask me, but I think it would be less maintainable and harder to test over time.
Gotcha. Cool. So with that kind of introduction, I'd love to just kind of start diving in. So I'm gonna start sharing my screen. And
Sure.
first of all, y'all should go follow Sage on Twitter, um, at the Segun Adebayo. And we're gonna be diving into Zag. So we're gonna look at I'm gonna put a link in the Twitch chat for Zag as well. Cool. So ahead of time, kind of in the green room, so to speak, we spun up a new Code Sandbox project, and we installed two dependencies, which were at Zag.js Core and at Zag.js React. Um, where should we get started? I think we had kind of talked about like maybe starting with some state machines first.
Yeah, for sure. I think like I have so many ideas here, but like we can start with like let's try to build a component from scratch. I think
Okay.
that would be a lot more interesting to see and to talk about. So like people actually get to see like how Zag works underneath the hood. As like Zag is not some special library or some state chart. It's just JavaScript, but we're using the way of thinking about components is using state charts, right? But how you write the
Mhm.
code, you see the difference between like both of them. right? So we're gonna let's try to build a, should I say, like the input type equals range, right? So that is a slider component,
Okay.
effectively. All right. So if we head over to the Mozilla, the MDN docs for this element, let's try to see if we can build a custom one, and then see how far we can use Statechart to model this. Right. So on this page here, we have like input type equals range. There are a couple of things we want to test. So this is in my, when I work on components, this is what I call like the discovery phase, where you're just trying to like discover like what functionalities does this component have, what accessibility features does it have that I have to quote unquote replicate within my component. Right. So there are two key areas here. So if you scroll all the way up to the example within here, and let's try to test that with the keyboard and with the pointer, right? So if we do keyboard focus on that element there and press like the left and the right arrow keys, that sort of like increments, decrements the value. You can press the home and the end key, takes the value to the end, takes the value to the start.
I don't have those on my keyboard, but I will take your word for it.
Yeah, for sure. So that would literally like take the value. If you press the home key, you take the value to the start, and if you press the end key, you take the value to the end. So that is basically what happens when you do that. Then as always, if you maybe like click at any point within the track itself, you'd also update the value, right? So that is kind of like what we'll try to build here today. That's an example we can build together. Does that work for you?
Absolutely. Let's do it.
Awesome. All right. So before we start writing code, the key ideas we want to learn today is the fact that like when thinking about like state charts, there are a couple of things that we need to talk about. The first one is the fact that like state charts and modeling components is a top-down approach, which means you need to actually design the system. I'm going to talk about what the system means shortly, and then you write the code for the system. Right, it's a little bit counterintuitive from the traditional approach, which is you just start writing the code, put a couple of use states and stuff, and it's all done. And then you start to add if else, use effect, use state, and like it's all done, right? So, we would like to take like a top-down approach of the system, and let's go through and explain what the system means. All right, so with the state charts, the key requirements you need to have is your component has finite number of states, right? So note one would be this component I'm trying to model would have finite number of states. The second one is it would have a finite number of events that this machine can listen to at any point in time. If you've used systems like, if you've used like Redux or the reducer pattern, you'd probably be used to like state and events. But the state is slightly different in this use case. So if you want us to maybe like, draw out something together, that would actually be helpful. So if you maybe can open Excalidraw or TL Draw, let's try and sketch something out. Together.
I'm wondering if oh, okay, cool. Yeah, and do I need, am I able to share this with you, or are we just doing this kind of on my end?
You can share this with me. I think it'd be cool. Yeah, there's that like just on top of the light dark mode switch on the left, top left. Yeah, that one. You can start a session and share that with me.
I'll call myself Ben. There we go. And give this in the little special Zoom chat. There we go. All right.
Nice, cool. I'll try to do this without actually like joining in Excalidraw, and if you run into bumps, I can get in there as well. All right, so let's go and do like, let's go back to the MDN docs and try to observe this component one more time. All right, so this component, what I say before interacting with this component, let's assume that this component is in what I call the idle state, which means prior to interacting with the component, it's just rendered on the page, so it's currently idle. Now, if you press like the tab key to sort of like, tab all the way to that component, you see this focus outline show up.
Yeah.
Right. So when this focus outline is on this component or this element, there are a couple of things you can do. right? And those things you couldn't do prior to it getting focus, right? So you can press the left and the right arrow keys to increment the value, and that is because it is now focused, right? Prior to it being focused, you cannot use the left and right keys to actually increment the value of that slider, right? Because hey, you're controlling the page, not the component itself.
Right.
Right. So that is kind of like that's kind of like point. And if you put your pointer down along the track of that component, and sort of like scrub all the way to the left or the right, you notice that you're in a slightly different state from what we were before, which had like this focus outline. Right. So I would assume that this is kind of like what I would call like the dragging state, where you're actually like dragging or scrubbing the values of the slider.
Mm-hmm.
So now we've been able to identify like 3 different states this component could be in: the idle state, the focus state where it shows the focus outline, and the dragging state where like when you use the pointer and you're going like this, then you're dragging the value.
So doing further exploration, it does seem like we could be in multiple states because I'm focused on this and I'm currently dragging, right? So
Exactly.
yeah.
Exactly. So, so you could also be focused on the dragging, but then while you are also dragging, I mean, can you test to see if you can use the keyboard, the arrow keys at the same time?
Yeah, let me. Okay. Yeah, it's like it works up until my mouse twitches.
Yeah, exactly. So that is what I would call like an unknown state. That's like that currently exists within the DOM element itself, because it feels like you're incrementing the value, but you're actually not incrementing the value. So that is quote unquote like a state misalignment in there. But let's try to see if we can actually model this correctly, at least on a basic level. We can go as complex as we want.
Okay.
So let's draw three boxes. One for idle. So we just put idle, the text idle in there.
Is there?
Yeah.
Yes. Yeah.
Yeah, you can just do like idle. And then we draw another box for focused.
We are not gonna make these especially pretty today, but
Yeah, no problem. And then let's make the other one. Let's call it dragon state, right?
cool.
All right, so let's space out these boxes so they're not like super packed. They basically like just like space them out, yeah, really far apart from themselves. Nice. Cool. So so now we need to figure out. So this is like the first step in modeling any component. You need to figure out the states that these components could be in. And then the next phase is you need to figure out the events that can occur in each of these boxes.
Okay.
So the key tenet is that Statechart makes like impossible events impossible. Literally, there's no way you can cause it. An event and like a bug by sending the wrong event. In the browser and with vanilla JavaScript, you can call on mouse move and on pointer move. These 2 events can be fired almost at the same time by the browser. And it's like with a state machine, if you handle that logic with a Statechart, it's just going to respond to one of them. It's never going to respond to both of them at any point in time. And that's because like you can be in one of these states at any point in time. And in any of these states you're in, you can only listen to a finite number of events, right?
Okay.
So even if you send an event twice, so let's say you're designing a payment system that says pay now and you click that button twice, because the machine has transitioned from being idle to actually processing your payment, clicking the button again would do nothing compared to like having to disable the button, because every state node has a finite number of events that it can listen to. So let's do the first thing here. So we're going to let's draw an arrow from the idle state to the focus state.
All right. Beautiful.
Yeah. And then I think you can double click the arrow to add a text. I hope so. No, you can't. So you can just put a text on top of that.
Yeah.
Code tab. Yes. Let's call it tab focus. Tab press, whatever that's it.
Yeah.
All right. So that means that when we press the tab key and we focus on this component, it goes from the idle state to the focus state. right? In this focus state, there are a couple of things you can do. You can press the key arrow keys. So let's just start with modeling the arrow keys, right? So you just, in that focus state, just type in arrow keys. I mean, I think we can, or we can put arrow left, and then also, in a new line, arrow right as well.
Yep.
Now, obviously,
There's
home
also
and
home
end
and
keys.
end, right?
Yes, exactly. All right, so all of these different events, they still keep you in a focus state, which means you still get to see the focus outline like at this point. So it's not actually causing any state transition compared to the tab focus event. The tab focus event takes you from idle to focus. So that is actually a state transition happening in there, as you can see there. So if we head over back to the MDN docs again, press the tab focus keys such that we are in the focus state.
Yes.
And then just click anywhere outside the page. Basically, what you've done is you've blurred, basically you tabbed out or you focused out of that element. That takes you back to what I call back to the idle state, where it's like, no interactions again. So if we go back to Excalibur to model this, we can draw an arrow from focus back to idle by saying that like the event here is focus out. Exactly. So there we have that event that says focus out. But then, so here we've been able to sort of like model out what happens in these two states. So we have one more state sort of hanging in there, which is the idle and the dragon. What's happening in the dragon state, right? So how can we get to the dragon state? If we go back to the input element and MDN docs again, one of the things we see, the only way we get to this idle state is if we use the pointer. This dragon state is if we use the pointer to click anywhere and like keep holding your mouse all the way. But then when you release your mouse, you're back to what I call like the focus state, where you can actually put like press left and right. But we need to confirm this. So drag along the track, drag along the track, release your pointer and press the arrow keys. You see that we are kind of like in a focus state when you finish that interaction.
Yeah.
So these are actually like hidden, should I say, like hidden gems in all of these elements, which is why people say like, don't try to make custom elements, just use the DOM, because like there's lots of like richness you get from actually using these elements. But then we're doing this for the sake of Statechart, so people actually see that if you wanted to model this complexity, how can you actually use the Statecharts to do that as well? All right, so let's go back to Excalibur again and say like we can draw an arrow from idle to the dragon state and say when I'll call it like pointer down. That would be like the event, which means when we put our pointer or our cursor or mouse down, but I like to call it pointer just so it's like more generic to the pointer type, right? So like when we go pointer down, we're in the dragon state. And when we actually release our pointer, we don't go back to idle, we go to the focus state. So let's draw an arrow from the dragon state to the focus state. Yeah, that's the pen tool.
Wrong. Okay, well, we're just gonna have a wonky arrow for that.
Yeah.
Such is the way. Yeah, all right, and this is pointer up, I'm guessing? Or like
yeah, that is pointer up, exactly.
Yeah.
Nice. All right, so this gives us a fair enough idea of like, all the different interactions that can happen within this element. So you put your pointer down, and you can actually like scrub. So in the dragon state, I'll just add one more text on there called like track pointer event.
Yep.
Right, so that is the state we actually like get to track the pointer events and like how, the pointer move event, basically. Right, so this is a fair enough idea. So the key thing here behind Statechart, it feels a little bit daunting to create all these diagrams to understand what's happening, but you get two benefits from doing this. One is you get a high level understanding of the interactions and the events that can actually happen within this component, as opposed to having some React code, use effects, use states, like, and it's actually hard to understand the behavior of that system. All right, so this is kind of like the overview of, like, let's start with this very simple use case and see how far we can go in terms of like modeling. So one last piece of state charts. Again, we talked about two. The first one is finite number of states. We already mapped that out. The second one is finite number of events. We already mapped out like all of the events in there. And then the third one, I call it like data. Basically, like, what piece of data do we need to keep track of as the element transitions between these states, right? So one interesting piece of data is the value it represents, like while I'm doing all of these interactions. So what I'll do is, I'll probably create a circle, just like put it at the center of that, of the O piece, and just like put a text, just put like value. And I'll also keep track of the step size.
Okay.
Right. So as I'm pressing my arrow left and arrow right keys, by how much do we want to increment or decrement the value? So that's what that represents. All right. So we can maybe do like minimum value, maximum value, and all this stuff. But let's just kind of like stick to value and step size to keep this all simple.
Makes sense.
All right. So that's it. So you basically like at least have the basic knowledge of like how to create a very simple state chart. So this is a state chart here that you built. Now the next thought generally would be like, what's the code behind this? How do I write some code? But like in the end, I think that this is a much valuable skill to learn compared to actually like just writing all the complex, smart looking code, because you can hand this over to someone who is just a junior engineer and they can understand almost instantly what's going on within the code itself.
And also something like this is something I could hand to like a product owner, right? And a product owner might not know like all of these things, but they're certainly going to be much more able to agree to all of these things than, if I'm handing them a bunch of code.
Exactly. And I think they can definitely also contribute to that conversation to say like, I think we are missing something here, or I think maybe we should also have like an extra arrow from here to here. At least they can speak the language of boxes and arrows more than they can speak the language of code. So that is definitely something that extra advantage we get from this process.
Absolutely.
Cool. All right. So now that we've modeled this out, I'd say like we're kind of done with like MDN, but we can keep it open. Let's head over to Code Sandbox to basically like write some code.
Good deal.
All right. So from Zag.js, you need to import this create machine. So you import create machine, the named import of create machine from Zag.js core.
Okay.
All right, so this function basically is what you use to model the diagram you just created, right? So we're going through the process now to sort of like figure out like what we want to do here. So let's create a constant in the next line called slider. Slider equals, and we call the create machine function.
All right.
All right, so the create machine accepts an object in there as the argument. And this object contains a couple of things, but we're going to walk through that. One of the things we looked at is a state machine has finite number of states, and we already mapped out the number of states already. So there's one of the key called states, just as you'd expect in there. And states is an object of like each state, right? So create an object. Let's create the first one for idle.
Okay.
So we put idle, just put an empty object in there. You can use small letters as well, it's fine. Generally, I tend to use like all caps for events, not states.
Yeah.
Yeah,
but like
we can kind of like stick to that. Yeah, idle, and then we create the other ones as well. Focused and dragon.
So we've got a states object with 3 states. Each of those states is our like a property in that object, and so we've got idle, focus, dragging, and currently they're all set to empty objects because there's not any configuration that's happened for each of those yet.
Yes, exactly. So before we go ahead to add like any of the configurations above the states property in that object, let's add like an initial. Let's type initial. So you use this to kind of like mark the initial state this component would be in, right? So you can automatically see that you can actually simulate the component to start from the dragging state or to start from the focus state automatically. But let's just start from the idle state.
Okay. So for the
For this use
initial
case,
property, am I just doing like a string with my state
yeah,
name?
you do like a string, exactly,
Okay.
exactly. So you see, like, so that's it. So now we have finite number of states, and we've marked out the initial state, basically, right? So next thing we want to do is, at least just for the sake of this demo, we talked about the data. We're going to look at the data and then look at the events. So the data is called context within like the state machine terminology. So we're going to add an extra property called context. And this property would be an object that holds the value. So we can start out the value at 0.
And these are just these are we can name these whatever we want, right? This is just things exactly. we know we need for our system. Okay.
Exactly, exactly. And then we have the step, right? So the step could be 1 for now.
Yeah. Okay.
Exactly. All right, so this is the second piece. And then the third piece, which we're going to get into now, is the events, right? So how do we model the events in there? So let's take a look at the diagram again and start from the idle state. So if you switch back to Excalibur, we see that in the idle state, there are 2 events going out of the idle state. There's the tab focus event and the pointer down event. Right. I think that we should pay attention to this a lot because like you can see that like every piece of state has like, I mean, finite number of arrows going out from it. So that means that if you send like any other event that is not like, I mean, that is not listed as part of these arrows, the machine is just not going to respond to that. So that is exactly what I mean when I say finite number of events and transitions.
Okay.
Right. So let's go back to, so we see that we have like the tab focus and then we have the pointer down.
Okay. Yeah. So
just give me 1 second. There's kind of like a sound from here.
Yeah, I'm trying to that be on my end or that on your end is. Hey Brent, welcome to the stream. Oh, okay, gotcha. On Segun's end. Gotcha. Yeah, no worries. And also just want to give a shout out in this moment to folks in the chat. We've got Brent in here. I see we've got Florian as well. Yeah, so what we're doing for anyone who's just kind of joining us at this moment, we are building a state machine that represents the logic for like a range slider input. And so to do that, we've imported a create machine utility from Zag.js core. We've given it 3 things so far. So an initial state, which is the name idle. We've given it a context object that has just some data we need to keep track of. And then we've got a states object with our 3 states are properties of that. So that's what we're up to so far.
Nice.
Yeah. Welcome back.
All right. Cool. Yeah, let's get to it. So right now we start from the idle state. So to model events in the idle state, there's a nested object called on. Right? So you add a property called on.
Okay.
Basically, on is an object, right? Just like the browser event system, like on key down, pointer down. It's just that this starts with on, right? And inside this object, then you put the events, right? So let's put the first one. I usually like to use all caps for events just to make it like very obvious. So let's say focus or tab focus. Yeah, I think that's consistent with that. All right, so this would take an object. We'll figure out like what to do within this object in there.
Yep. Right.
All right. So in the same way, in a similar fashion, let's just put in all the different events, like using the same pattern. We just go in. The other event is, I think, pointer down. All right. So we just like put pointer down as well. All right, and then yeah, I think we can definitely just take a quick sweep at like the other ones. But before we go into the other states, let's just like get into what happens inside these objects. And then
Yeah.
we can do the other two states. So let's start with the top focus. So if you go back to the diagram again in Xcali draw, it kind of feels more like if you look at the tab focus arrow, it goes from idle to focus. So that feels more like a go-to focus state, basically. All right, that's sort of like the pseudonym of like explaining what happens in there. So let's go back to the code and see how do we represent this go-to focus state. All right, so you put a target property on there,
Okay.
and the target basically points to the state as a string. So the string
Gotcha.
representation of the state you're going into. All right, so we saw the diagram that goes to the focus state. Exactly. All right, and then let's do that. Let's do the same for the pointer down.
All right, and so this is, we know that that's going to go to dragging. All right.
Nice. Cool. Right. So now that we at least understand the basic structure of this, let's sort of like put together the other events pretty quickly.
All right. So focused is an object with a nested property called on. On, we know we have really only one event, which is pointer up. Oh, sorry, we're on focused.
Focused, yes.
Yeah. So it's the only event coming out of focused is focus out. So
yeah, I think that we should maybe like think about it some more as well, because even if you have the focus outline on the element, you can still do the pointer down event, which means like even though it's focused, you can still use the pointer again to actually like drag and change the value. So let's do the focus. I'm just saying we definitely need to add one more arrow to that.
okay.
To that state, exactly.
Yeah. So
So
focus.
we should yeah.
Focus needs an arrow. Where there's the arrow. So gross, but we're saying we need to go from focus to dragging.
Yes.
Okay, and for this is this also going to be called pointer down? Like, is it the
Yeah,
same?
exactly. Same
Okay,
same event. Yeah.
got it. All right. This is gross and becoming unreadable, but you get the point. Cool.
Yeah, I think I
So
will definitely figure out how to like bend the arrows or something, but it's okay for now. Right, so let's model this out. Focus out goes back to idle, and then pointer down goes back to dragon.
yep. All right.
And then we have a bunch of like keyboard events. For now, let's just do the arrow left and the arrow right.
Okay. And
Right.
gotcha. These are still in our on because even though they're not really transitions, they're still events that we care about.
Yeah, there's still events we care about, exactly.
Okay.
So we're gonna skip this one for now. Yeah, just put arrow left, arrow right in there. So the interesting things about this one, these events is they don't cause a state transition. So they just do stuff. They don't really cause the component to transition from like any state in general. And most of the time, I mean, in this use case, what they do is they increment the value. So their actions that they actually like carry out in general. So let's try to see if we can model that here. So within the arrow left and arrow right keys, you can pass in something called actions.
Okay.
All right, so actions a property in there. So let's just put a string representation. Let's just call this decrement value. Just put a string there called decrement value.
Okay.
Yep. And then arrow right would increment the value.
Yeah. And increment value. Okay.
Exactly. So we're gonna so for the dragon state, we can basically just add the events for that as well.
Okay.
Pretty
So we add
quickly.
another actions into our dragging, and this
I
time
think we have the on key.
Oh, right.
You know, it's a state of its own, so it starts with the on key.
Yep. On.
And then we sort of like put all.
You like?
I think it's pointer up or something like that.
Okay, I see what we're doing. Yeah, starting all the way from the pointer up.
Yeah.
And that's gonna take us to focus.
Target. Yeah, exactly.
Okay.
Then what other events did we see there? I think that is the only one.
Yeah. So
Yeah,
we're
that's
gonna
the only one
need,
out of Dragon.
yeah.
So we're gonna talk about that like track pointer. What exactly does that do? So that is so that's sort of like I call this like is a subscription or an activity because it's a long running activity compared to a single action like increment value or decrement value, right? So
Mhm.
I mean the actions are like once, like they just execute once, just like fire and forget, which
Okay.
means like you increment the value once and that's it. But then the one for the dragging state is called track pointer or track pointer move, largely because like they actually like run for a long time. They add an event listener to the document. They remove an event listener from the document, right? So that is what I call like something that you subscribe to or an activity, basically. Right, so there's a key in every state aside from the on key. The other property you can pass in is called activity.
Okay.
All right, so you can just like outside the on key, you can pass in activity. So let's just put a string called track pointer move. All right, so that just puts an activity. What activity would you like to do within this?
Okay.
All right, so I mean, I think like for the sake of time, what we will do is let us try to get the arrow left and arrow right functionality working. Right, so I'm gonna come in here into the hold on a second, into the code sandbox down here. If you scroll all the way down,
Yep.
right, so there is a second this is second like argument that goes in there, which is an object, right? So in here within this object, what we pass in there is like the implementations of all of these different strings.
Okay.
Right, so you see we said activities, we said actions, so like this is where you actually get to specify like what do they do effectively, right? So let's kind of like dive in here in this implementation. So let's go into the object and add two properties called one is called actions.
All right. Actions.
Actions is an object,
All right.
and then we'll put in like decrement value, a function called a decrement value function, and increment value function. These will serve as the implementations for the strings above, right? And then the other one is activities, just like you guess. So the other key you can put in there is activities.
All right. Yep.
Yeah, and that also takes the track pointer move. Cool. Nice. So let's get into, for sake of time, let's get into like what the implementations here would do. Right, so I'm going to just type it in here. So every action basically provides you the context, which is that data that you put up there when we started writing this. So that data that included the value and the step, that is actually what is included within this decrement value. So I mean, so all of these implementations get the context, and if you scroll all the way up, you see that the context is actually an object. If you can scroll up now, let's just take a look at the context one more time. The context includes the value and the step size. All right, so let's just start with this basic implementation. And what we do here when you see a decrement value, basically what this means is you grab the context of value, and you're basically decreasing the value. And that is as far as like the implementation goes. And then the increment value will basically like incrementing value. And that is as far as like incrementing value goes. It may seem like, I mean, this looks like so simple, but like literally this is the core idea or core concept behind the state machine itself. Right. So let's kind of like test out the keyboard interactions. I mean, let's just at least build out this component and just like put some interactions around this. All right, so to make this like super fast, we need to build out a UI. So right now we've spent so much time on the logic. It's time to kind of like do like a little bit of UI design work here, right? So let's kind of like just like get rid of all this.
Mm-hmm.
I'm gonna just create like a div here. Let's call this, we give this an ID of the, let's just call it like the slider root.
Okay.
And then we basically just have like another div in here whose ID is the slider thumb. Right. I'm not sure if you need like the track itself, but let's just add one more part here. I'll call this the slider range or the actual indicator for the slider value.
Okay.
All right, so let's just try and style this so that there's something actually like on the screen instead of this looking like super weird. I'd head over to like the CSS, the styles.css file. And then I'm just gonna add a couple of styles in here. So let's do the slider root. I think maybe instead of calling it slider root, let's just call it the slider since it's the container for all of that. So we do like the slider, style that by ID. Let's just set like a width for this pretty quickly. So since this is not exactly like a CSS stream, we're just gonna like go through like all of like the different things in here. We can set a background of light gray, figure out like the contrast later on. And then we can set like a border radius in here. Let's just say like 4 pixels so it looks rounded. And then we'll come over here to the slider range, right? So let's try and style the slider range. All right, so this would be like a background of, let's just say blue for now. All right, and this will also have the same height as the parent. The only difference is we're gonna have to control the width of this element. So just for demo purposes, I'll put the width is 40%, so we can actually see that it looks like some sort of like range that is ready to roll in there. I'll just add overflow hidden so it clips out like the edges and the border radius shines through in there. So let's switch over to the slider thumb. So how do we style the slider thumb? All right, so I'll add in like a width property. So let's just say this is 24 pixels. And then let's say this is 24 pixels as well. Adding a background color, same as blue. And then figure out why this dude is not showing up on screen. So we've got this slider and then we've got this slider thumb.
Is it
with an height
going up after the overflow? Is that what's happening?
Oh yeah, true. That may be
Yeah,
the
there it
reason.
is.
So let's kind of move the border radius over to the range. That's a good point. And then the border radius, we can just set this to 999 to make it like perfectly rounded in there. So now we need to figure out how do we position the slider in there somehow. So the first thing I'll do is I'll just use like set position relative on the slider itself, and then set position absolute on the slider there. Or maybe I could definitely like also think about like just leveraging like the flexbox model as of absolutely positioning that. But then we have like position absolute in there. We can set like the top. Let's set the top to like 50%. And then we check like, okay. And then I think like, what's that technique again to sort of like center stuff? We do translate. Let's do a translate here. Y negative 50%.
I don't think it needs the quotes, right?
Oh yeah,
There
I'm
we
so
go.
used to CSS and JS.
I gotcha.
Yeah. Awesome. All right. So now what all we need to do is basically like change this like left value. So if we do left of like 20%, it basically like goes like that. So
Hmm.
now we set up like the basic like bare bones of like the styling structure. So the
Hmm.
next thing I'm going to do here is I'll create a CSS variable at the top to actually like control this offset. I'll
Hmm.
just call it offset for now. I'll make that value 40%. And then I use that variable to control the width here. So I just call that var and grab the offset. Then I'll use the same variable to control the left positioning of this thumb. Right. So I create that var and make that also the offset. Right. So now we get like the slider component in there, but you notice that like it's like super like far away. It should be like, at the center there. So we can definitely like adjust the left position
Hmm.
based off of the width value itself. So I'm launching a calc there to sort of like subtract out like just that width right there. So we have that like looking kind of close. So how I got the 12 pixels, the width and height is 24 pixels. So like just use that half of that to like offset that to the center. So that gives us like that leaves us with like a singular CSS variable that we'll use to
Hmm.
sort of like control the position of this. And you can see that this is already getting us pretty close to the value. So if I said 20%, we can see the slider goes to 20% automatically.
Yep.
So in the end, all we need to do is to grab this CSS variable with JavaScript and update the value, and we're sure that like the component works correctly. All right, so now let's get into like the accessibility semantics in here for the sake of time. All right, so in the slider here, it kind of depends on what we want to refer to as the slider itself, because these are like different parts. You have the slider, you have slider range, and you have the slider thumb. By default, the browser uses the container as the slider. All right, but then in the area specification, they also recommend that you could use the thumb itself as the indication of value
Okay.
for the slider. So it kind of depends. But I mean, what I'll do is I'll stick to using the container in this use case. So what I'll do is I'll set the role of this element to slider. Again, these are like accessibility semantics in here. And then I'll set values like the area value mean, which is the minimum value. And then we have the area value max, which is the maximum value. For now, let's just use 100 in there.
Hmm.
And then there's an extra property for accessibility called area value now, which actually maps to like the current value of the slider itself.
Okay.
Right.
We can
So
get
for
this
now,
directly from our machine, right?
yeah, exactly. So we're gonna figure out like how do we like get this directly from our machine. So for now, let's just put in 40. And then
Hmm.
we figure out like how the machine plays that role in there. To make this component focusable, we're gonna add like a tab index of 0, assuming it's not disabled, of course. If
Hmm.
it's disabled, then we can dynamically change this value or this property there. Another property we can use area value text, which represents like the textual value of that slider. So even though the 40 is just a number, you need to say something like the quantity you've now selected is 40. So that actually gives a more like human readable context to that value.
Hmm.
For now, we can skip that. We'll come back to that. Let's just really move on from here. So how do we use this machine logic that we built in this component? So if you test now, you see that you can actually like focus on the element itself
Yeah.
with the keyboard, which is amazing. Now we need to figure out like how do we like increment or decrement the value using the arrow keys, because nothing is happening right now. So let's connect that to the machine. All right. So to connect that to the machine, there's a hook called useMachine. So you can import this hook at the top. Let's import the hook from Zag.js React. Again, the main essence of this is like you write your logic in a framework agnostic way. And then you integrate your logic into a framework. So we have Zag.js React, we have Zag.js Vue, Zag.js-solidjs, depending on the framework that you use.
Mhm.
Right. So now that we have the useMachine, I'm gonna put like all of that Slater logic that we just built inside that. So now it's kind of primed and ready for React system of reactivity, basically. All right, so let's look at this. If you go all the way here, what this gives us is two things. I call it the state and send, but I'll call it dispatch just to help people get more familiar with this.
Okay.
Right, so state basically represents the current state of the machine, and the current state includes the value, like is it an idle state, dragging state, and also the context, which is like the data that we looked at, the value and the step size and stuff like that. So that is what dispatch is, basically the function you use to send events to the machine. We looked at all the possible events that you could send to the machine: focus out, pointer down, arrow left, arrow right. Those are possible events.
Mhm.
Now with these two properties, you can now like connect that to your UI. Like just like hook into the browser event system and use that to send events to the machine itself. All right, so down here we'll do like on focus. Yeah, what we want to do here on focus basically is we just want to dispatch the tab focus event. We talked about that earlier. So basically, when you focus on this element, you just dispatch that tab focus event in there. And then the browser event system has like an on-blur, basically, which means like when this component loses focus, let's say when you click outside or when you press the tab key outside, I think the name of that event is called focus out.
That seems right. Yes, it's focus out.
Right, so we put like focus out there. So now we've handled basically the different events. So now you see that at this point, all we are doing is basically dispatching events to the machine. We're not handling any complex logic within our UI in general.
What I'm actually gonna do just to show this off is I'm gonna stick a free tag at the bottom, and I'm gonna do JSON.stringify, and we'll pass it the state we got from useMachine, and then null2, and this way we can actually see in our code sandbox the current value of the state object. And so
exactly.
Now if I focus on this, you can see that like we had an event which is tab focus, and
you can just refresh. You can just refresh the page again. Yeah, this gives you that exactly. So you see that you get that event focus in tab focus and focus out basically being called when you press the tab key. And then you can see that there's like the value and the previous value. So that tells you like what the state this was actually in before and the state it is now. And then you can see things like the next events that can actually happen at the current state.
Oh, okay. So these are all the current like valid events that could happen that won't be ignored, like
exactly, that won't be ignored. Exactly. So that means if you send any other event aside from this, it's just going to be ignored basically within the machine. So now let's kind of like undo like the keyboard events in here. So I'll invoke the key down, grabbing the events, and I'll just like check on like the event.key, the event.key property. So let's just say like if the event.key is arrow left, what we do here basically is to dispatch the arrow left event to the machine, right? And then again we can switch on the arrow right, and then just say like dispatch the arrow right event. Now all we've done is basically hook into the browser system, event system, and sort of like use that to send events to the machine itself. And now let's see like what happens when you do the interactions.
Yeah, I'm looking at the value and the context, and it is, it's going up and down.
Exactly. So now we see that the context value is actually like now changing. And now you see that like all of the logic and all of the things are actually happening within the machine. And all you just need to do is to glue that to your UI. and it just works, right? So now let's just see how we can make this work correctly the way it's designed.
Mm-hmm.
I'm gonna wrap this up. So the first thing I'll do is to, if you scroll all the way up here, just scroll up a little bit, you see me there. I'll grab the state.context.value because I know that this actually gives me the value itself. So, I mean, I grab the value from here. Now let's try to convert that value to a percentage. So what I'll do here is basically divide that value by 100. Again, I'm going to assume that the max is 100. So it's kind of clear. I'm going to divide the value by the max to give us that like percentage in there. Right. So what we're then going to do is remember that in our CSS, we actually add this, like if you switch over back to CSS, you see we add this dash, the offset variable. So now we need to control this offset variable directly from the machine itself. So if we come back here, we're going to just like do offset is basically the percent. I'm just going to add the percent sign to that, basically. So that gives me the offset. And now to control this within the machine, I would add like a style property, and then just do like the offset variable, and then assign that value to the offset. Right.
Okay.
From here, I'll probably just add a padding to the entire app, just so we have that like little bit of space in there.
I think so. The value is already an integer, so what the percent stuff has done is basically made it like, when we have the value 23, it's setting it to 0.23% overall. I think we
Oh
just
yeah,
need
yeah.
to do. I'm just gonna.
Yeah, for sure.
Yeah.
Oh yeah. That's awesome.
Yeah.
Sure. Awesome.
I'll just do that real quick.
Yeah, let's do that.
And that way we'll be able to like more properly see expression. Oh, it's transpiling. Okay. Yeah. So now, yeah, now it actually kind of moves at a scale we could expect.
Exactly. So now let's try to sort of like factor in the step size here, because all we've done so far in our machine is just to increment that value by 1. So I think the better thing to do is to change that expression to like context of value equals context of value plus context of size. Exactly. So we need to sort of put the context of step size. Yeah, so you have like context dot value the step size. It should be context dot step size.
Oh, is it real? Oh, I gotcha. Yes.
Yeah, because that's
Yes.
an object of those two properties. Exactly.
Okay. Yes.
All right. So now let's set up the context. Let's set this up to increment by 10 instead of 1. So it feels a bit more interesting. Now we can sort of like focus on like increment that value by 10. We just like refresh the page and press sandbox.
Yeah, it's hopping
Focus.
up 10 at a time.
Yeah, and then
Awesome.
exactly. So that so this kind of like gives us like the general feel of actually like building like interactive components. For the sake of time, we could definitely go into like the pointer events and set up the dragging state. But I mean, I could maybe like just touch on that briefly if you're interested. But the main idea here, as you've seen, is that like the entire slider variable in line 5 is completely framework agnostic. And the only time it actually interacts with your framework is in line 65, where you call the useMachine hook. And then every other thing is left to you. The UI is left to you. And you just like handle whatever use cases you have within your UI correctly.
Absolutely. And this means that like our logic, like we could put this slider machine. I'm guessing we could put this just in a shared library that like, my team has access
Exactly.
to, and we could use this in our React apps, in our Vue apps, and web components and stuff like that, just so long as there's that bridge.
Exactly. And that is literally what Zag.js is. So Zag.js is that collection of like logic that you can actually bring into your application and style automatically.
Gotcha. Very cool. That is awesome. And I'm just gonna go now to the Zag homepage and take a look because, um, the dream here, right, is that, I Ben Myers don't need to know all of the slider state to have a slider machine, right? Like, because you're doing that, you're handling that. So like, I'm on the Zag homepage. I'll go put in a link to the introduction in the Twitch chat there. But like on the left hand side, I can see a nav with a bunch of like, I'm guessing these are just basically the machines, more or less.
Yeah, those are the machines, exactly.
So I could
So
go
you
to
click.
slider or range slider, yeah. And we can see like this is implementing what we've just done, just only
Exactly.
a lot more.
Exactly. This is
Awesome.
literally all there is. And we just basically put that within a package called Zag.js slider. You can install that and use that automatically. I think what we do, I mean, other than what we've just seen today, is all of the event handlers that we had to attach to the components. We do that automatically as well from Zag. So you don't have to think about like, do I attach it to on key down or on key up? What we do basically is to give you access to an object, and then we just tell you to spread that object onto your element. And when you spread that object, we attach the correct attributes, the correct event handlers automatically. So you don't have to think about them. So your main goal now is just build the UI and that's it.
That's awesome. Um, this has been really cool. Unfortunately, we're a little over time, so I want to start wrapping up. But
Sure.
before we do, I just wanted to ask: is there something like what are you working on that like you're really excited about, or like what do you think folks using Zag should get excited about?
Yeah, I think like one of the things that like people using Zag should be excited about is the fact that like one, it works across all frameworks, right? Majorly like anywhere JavaScript can work,
Mhm.
it can work in there. So right now we have support, as you can see, for Vue and solid.js automatically, like out of the box. So like we're basically using the same set of machines, and actually like, I mean, giving you code snippets of how you can share this across frameworks. And one of the things we're also doing is to help you visualize what is going on behind the scenes. So if you scroll all the way up, there's a little tiny button on the website called Visualize Logic. If you click on that button, you basically get sent to like a website that sort of like shows you like the logic that we have behind this letter
Oh,
component.
okay.
Right. So this is like, no, we're not trying to hide some sort of implementation from you. Basically, you see like the logic that's going on. And you can see that some of these are pretty similar to what we did. You can see the arrow left, the arrow right. You can see pointer move and pointer up in there as well. So you can see there's some sort of similarities between what we've just built and the actual production code itself.
That's awesome. I really love that, and I'm willing to bet uh this is built with like web tech that's probably a little more screen reader friendly than our humble little Excalidraw canvas drawing. Um, I bet. Um, that's awesome. Hey, great work with this. This is super cool, and I'm looking forward to seeing more from this as time goes on. Because we were kind of talking beforehand, right? And like one of the core things about Zag is that on like you don't really need to use Zag directly. Like, it's entirely possible that component libraries, like especially Chakra UI, but like any component library really, can pull in Zag. And so you might be using Zag without even really knowing it, right? Like, this could blend into
Exactly.
anything. It can become a part of anything. All will subsume Zag. Um, that's awesome. All right. Well, hey, thank you so much for your time. I'm gonna send people to your Twitter. Go follow Segun, and just give him that semantics love because he's done a fantastic job here. I think we can all agree. Um, Stick around, chat. We are going to raid. Also, while you're following people on Twitter, go follow Semantics on Twitter. That way you'll keep apprised of all the streams going on. Next week, we've got Anthony Campolo returning to the stream. He's going to be showing how to deploy to the decentralized web using the interplanetary file system. I have no clue what a whole lot of that means, and so I'm super, super excited to be learning more. And yeah, y'all stick around. We will find someone to raid, but thank you all for being here, and have a great rest of your Tuesday. Bye, y'all.